Hello and welcome back. A key aspect of dealing with data is proper metadata handling. So let's look at what metadata actually are. Metadata are data about your data or data to describe your data. So for example, what are metadata? Metadata describe your data. Let's take this very simple photograph I took with my smartphone in a lecture hall. And you already see there's a lot of metadata stored along with it. We have the date when it was stored, or the camera it was in my phone, where it was stored as a geotag, and so on. So metadata are data about our data. They provide information about the data, like very generic ones, like the author of the data, the date it was created, location, and so on, but also very specific metadata that are unique to the type of data that we handle. So we, for example, can augment unstructured data like images, videos, text, and so on with structured information, as we've seen in this simple example. And that helps us to make data searchable and findable. So once we have, for example, the image tags and geotags, we can say, give me all images at Aachen University. It also allows us to integrate the data into our research data management systems. So we can have the metadata in our electronic lab book or laboratory information system, and the data themselves will be on some storage system. And then we can use the RDM system to find the relevant data for analysis. So here are some examples. If we have a text like a paper or a scientific article, we have like the author and the publisher, the publication year, or the DOI, the title, language, the size of the text, the version of the text if we have multiple iterations, the topic, or if it's maybe a newspaper article, the sentiment. If we have audio, we have similar information like who was speaking, for how long, how many speakers do we have, what were they speaking about, which language or music genre, and so on. If we have our scientific data, like for example this electron microscope image here, a lot of metadata is typically embedded in this information already, including which scientific instrument we use, the device and the model and the software version, but also settings of the microscope, for example, that were used during the acquisition of the data. So how do we treat metadata? Here we need to devise a schema that defines the structure of the metadata. Here we need to define which fields do we have, so what kind of metadata can we extract from the data, or how can we augment the data, possibly which type of this metadata do we have, and we need to decide which is mandatory and optional. There are some general initiatives for handling metadata, and of course they can only be very generic. So there is the DCMI, the Dublin Core Metadata Initiative, and we have there a set of standardized or general or generic metadata terms that are standardized in many organizations. They are typically used for web documents, and you can see here already an example where we have elements that have at least one or more of these metadata tags, and each tag can have a lot of properties, so we have many terms. And you can see this is very generic in terms of text, for example. There are also specific initiatives that are focused on more specific types of data, like DataCite for the identification of a resource and citation for retrieval purposes, the Data Document Initiative, or the Biodiversity Information Standards, or the Ecological Metadata Language, or OMERO or OME as a client-server software for bioimaging, and so on. In healthcare, we have the Swiss Personalized Health Network. So there are lots of initiatives that focus on describing data with metadata. Having access to this metadata also allows us to enter data into catalogs. These are like specialized search engines for metadata and metadata schemas. So metadata describe our data and augment our unstructured data. They help us to make data fair and make them data findable in our RDM system, in our electronic lab notebooks, in data archives or repositories. There are a number of metadata standards. They're very generic ones, but also specialized ones for a given community. Once we have such a metadata schema, we can have catalogs and dedicated search engines to help find the relevant data and metadata, but also specialized metadata standards. So if you deal with data, it's first of all a good idea to see if there's already an existing metadata standard that you can start to use. Maybe it's not sufficient, or if it's not existent, you need to develop your own, but try to be as generic and general as possible. Keep in mind that you want to share your work with others. So if you go down this route, you develop a de facto standard in your community and try to reach out to different members of your community and make it more generic so that everybody can share. Let's take some exercises for this. Use the catalogs that you can find and see if there are metadata schemas that are relevant for your specific field or application domain. And if there are, see if they match your needs. If no metadata schema exists or if it's not sufficient, start to create and extend metadata schemas for your domain. Start with a very specific application and use case maybe, and then revise and discuss with your colleagues. Can maybe cover another use case and repeat the exercise. And then when you have a metadata schema that you're not happy with, try to implement it in your chosen RDM or ELN system. Maybe as another exercise, look at the relevant data from your project that you're working on. Which metadata can you extract automatically, and which metadata need to be added manually. Ideally, we want to favor automatic extraction of metadata over manual entry. If the metadata can be extracted automatically, see if there's a suitable tool that can be used already for you and can be integrated with your chosen RDM system. If not, maybe write some tool and document the software and give it back to the community.